Hello folks, welcome to today's video. Today we'll be talking about surface area, an introduction to surface area. We're just going to talk about why we use surface area and some vocabulary today, and then in the next video we'll get into some actual calculations. So surface area, when am I ever going to use this? So as a teacher, right, I hear this question a lot in a math class. Why are we learning this? When are we ever going to use this? And usually I have an answer for that, but especially for things like surface area. When we talk about surface area, it is a very, I call it practical versus theoretical math, right? It's something that can be used in our everyday lives, really. So when am I ever going to use this? Well, we might use this if we wanted to paint our house, right? If I wanted to paint my house, I would want to know how much paint to buy. I wouldn't want to buy too much or too few, and I could figure that out by doing some calculations, figuring out how much wall surface there is to paint. Farmers would use this. They'd use this to figure out how much wrap to get for their hay bales, how to organize their gardens or their farms, right? Um, Gift wrapping, right? If you wanted to wrap someone a present, you would need to know how much wrapping paper to use, right? Again, that is surface area, covering the surface of a three-dimensional object. Manufacturing companies need surface area when they're trying to find the labels for their products, right? And there's all kinds of jobs that would use surface area on a daily basis, not just once in a while, but probably every single day, right? I mentioned how when we paint a house, we would need to use surface area. Well, that makes sense. A painter would need to do that the same, right? They would need to calculate the surface area of the walls that need to get painted in a house in order to know how much paint to buy, right? Chemists need to use surface area. Reaction rates and rates of dissolving all rely on surface area. The more surface area, the faster something will react. So if I think about mixing in a tablespoon of sugar into a coffee versus a sugar cube, right, the tablespoon of sugar will, or teaspoon of sugar will dissolve faster because there's more surface area. Well, the same thing is true for chemicals or reactions, right, like iron. Iron shavings are very reactive, but a massive iron is not. A dentist, right? A dentist would need to use surface area in order to make the appropriate size dental implants, bridges and crowns and things like that, right? In order to not change the way that a patient would be chewing. Gift wrappers, again, another one we talked about, but it makes sense. If someone wraps gifts as a profession, right, they need to know how to find surface area in order to know the appropriate amount of wrapping paper to use, right? Again, too much, they would use too much supplies, not enough, and they'd have to restart. Construction. Construction's a big one, right? If I wanted to do siding, sheathing, drywall, floors, roof, right? Whatever. There's all kinds of surface area going on in construction work. Gardeners. Gardeners need surface area to know how much product to put into their gardens, right? Seed, fertilizer, weed killer, all these things. They don't want to use too much or too little, so they would have to find the surface area in order to know the exact amount. Paving companies, same thing. Carpenters, again, same thing, right? All of these professions would use surface area in order to figure out the amount of product that they would want to use. An artist, right, might seem kind of silly to think that an artist would be calculating surface area, but again, it comes down to how much or how big they want something to be or the amount of product they want to use, right? So they could use surface area to calculate that. Okay, so I've said a lot. Surface area. Well, what is surface area? Surface area is the sum of the area of all the faces of a 3D object. And when I say faces, I mean the sides, right? If you think of a three-dimensional object and you were to pull it apart into all of the two-dimensional shapes that make it, right? If I could find the area of all of those two-dimensional shapes and then add them together, that would be my surface area. So we have a couple of specific names for the sides and the types of three-dimensional shapes. So for example, a base. The base tells us the type of three-dimensional shape. And what I mean by that is this shape right here, we would call a rectangular prism because it has rectangles as its base. Whereas this shape right here, we would call a triangular prism because it has triangles as its base, right? So the bases are on either side. So we have different types of three-dimensional shapes. We have what we call prisms, and that's the two I just talked about right here. Prisms have two parallel congruent bases. Parallel meaning they go off in the same direction, and congruent meaning that they're the same shape. Pyramids only have one base, so this one right here we would call a rectangular pyramid because the base is a rectangle, but it only has one. And cylinders have two circular bases. Right? So this last shape up here we would call a cylinder because there is a circle, and there would also be a circle kind of down here that's hidden as two circular bases. Faces are everything that's not a base. So if in this shape here, let's say this was my base and this was my base, then the other 1, 2, 3, 4 sides of this shape would all be called faces. Okay? All prisms will have rectangular faces. Whether it's a rectangular prism or a triangular prism, it doesn't matter. The faces will always be rectangles, whereas pyramids will have triangular faces. And again, even though this shape right here is a rectangular pyramid because the base is a rectangle, all 4, 1, 2, 3, 4 sides of it are triangles. Okay? A net is a two-dimensional diagram of a solid figure. So if you imagine for a second a three-dimensional shape that you were to pull apart, right? If you were to pull it apart, you'd be left with this flat piece of whatever it was made of, right? And that flat thing would be a two-dimensional shape, right? So we call that two-dimensional shape a net. So for example, if I were to take this cylinder and unravel it and look at the two circles, this is what its net would look like. Same thing with this triangular prism here. If I were to unfold the triangular prism, I'd have two triangles, right, and three rectangles. And it could be useful to think about the net when we're trying to find surface area. Okay, and height. The height of a the height of a three-dimensional shape is the distance between the two bases. Usually we think height as being vertical, but that is not always the case. It might be, like in these 1, 2, 3 shapes here, the height is a vertical distance, right? Because the bases are vertically distant from each other. But in this fourth shape over here, the height isn't vertical, it's kind of lying down, right? Even though it's not vertical, we still refer to this line right here as the height because that is the distance from base to base. So, surface area means the area of all 2D sides of an object, right? To find the surface area of an object, we find the area of each side and add the area together. Right, so that is the basic gist of it, right? Once we know the area of each side of my object, then it's just a matter of adding them together. Okay, so that's it for today's video. In the next one, we're going to talk about the actual numbers, the actual calculations of surface area. So I will see you all in the next video.